Hello my dear students, welcome to this presentation on how you find the derivative using what is called the first principle. Alright, so in the class we explained the physical meaning of the differentiation and then we derived this formula dy by dx equal to the limit of f of x plus h minus f of x divided by h when h approaches 0. We call this formula first principle, right? And also we discuss what is the main issue we face here, which when we want to find the value of dy by dx. The main issue actually here is this h. Well, I would say this annoying h, right? So all what we are going to do is how to get rid of this h, and then we can easily find the derivative dy by dx by substituting h equal 0. Right? So let's demonstrate this on the following example. Alright, let's take this function f of x equal to x to power 2. What I advise my students always when they solve such questions is firstly to write the formula for the first principle. Right, so I write this again, dy by dx equal the limit f of x plus h minus f of x over h when h approaches 0. Actually, the reason why I ask you to start with this is the following. When you have this formula, you ask yourself, well, what I do for the next step? Alright, so I need to find what? I need to find or determine f of x, and then f of x plus h. Together we substitute, and then we find the derivative dy by dx. Alright, so dy or x squared we already have here, which is f of x. Now we need to find f of x plus h, which simply you need to substitute every x appears in the formula, this formula, other formula, alright, with x plus h. So this is x plus h to power 2. Now we take this and substitute in the formula. Alright, so dy by dx equal to the limit of x plus h to power 2 minus x squared over h when h approaches 0. Right, the question now, can we simplify this? Yes, of course, we can simplify it. It's by expanding x plus h to power 2. So this is the limit of x squared plus 2x h plus h squared. This is very simple and straightforward, minus x squared all divided by h when h approaches 0. Can we simplify? Yes, can. So x squared is x squared, and as you can see here we have h as a common factor. So continue. So this is equal to the limit of h 2x plus h over h when h approaches 0. This is actually the moment or which we are waiting for, because all what we did is to to get rid of h, and now you can see we can do it here. Alright, so h and h cancel. Alright, and we are left with the following formula: limit of 2x plus h when h approaches 0. Good. Right, so now you see it's time to substitute for h equals 0, and remember please that you always need to write the limit when h approaches 0, okay, until you reach stage where you can safely substitute for h equals 0, which we already have now. Alright, so x goes to 0. Alright, so this is equal to 2x. So the derivative of x squared using the first principle is 2x. We all know that using the standard formula, right? Using the standard formula, the derivative of x squared equal to x, which is exactly what we obtained here. Okay, and this method, actually you can use it to find the derivative for other functions, okay, probably a bit more complicated functions. Okay, thank you, and I hope this video helps you to unleash your potential.